right?
Awesome. Thanks, everyone.
Thank you, Vignesh. Thank you, Vipin. We're going to move
guys.
right into the EKS Connector bits. We had talked about it a couple times already today, how you can connect a Kubernetes cluster running anywhere, any compliant Kubernetes cluster, into the EKS console and connecting it to EKS as a service. So we're going to bring in Lee Chun and Raphael. Hi, Lee Chun.
Hey, Justin.
Hey, Raphael.
Hello, how's it going?
It's going just fine. How about yourself?
Not too bad, thank you.
So, Lee Chun, tell me what you do at Amazon, what you've been working on.
Yeah. Hi, everyone. I am a product manager from the EKS team. I've been working on EKS Connector and actually EKS Anywhere.
How about you, Raphael?
Hey, so I'm one of the engineering managers here at EKS, and I've been working on the EKS Connector project for some time now, as long as I joined EKS in the beginning of the year, and I'm very happy to be here with you to share that project with you.
And I know EKS Connector launched last month, if anyone noticed the launch blog. Lee Chun, can you tell us a little about what it is and what it's for?
Yeah, so we actually entered the public preview with EKS Connector on the same day as EKS Anywhere GA. And however, the connector itself is a EKS, Amazon EKS overall feature. It's a capability that you can use to help you connect just about any cluster, not just EKS Anywhere cluster, but any cluster running anywhere to the EKS Service Control Plane. More specifically, it's an agent that you can install on your cluster. As soon as you provide appropriate permissions to it, you're going to be able to see the cluster showing up on the EKS console side by side with your EKS cluster in the cloud.
So I have hosted EKS clusters running. I see them in the console. I have my Kind cluster running on my laptop, and I want to see it in EKS console, and I want to be able to use some of the EKS features with my Kind cluster. That's what EKS Connector is for?
Yep. You get it right.
That's pretty amazing. and what is it using for, how is it doing that connection? You mentioned it's an agent, but what else is involved? Do I need a VPN to Amazon? Is there something that I need to make that connection secure and available?
Yeah, so actually we will dive a lot deeper into, let's say, network requirements and all of that. But why don't I start with explaining how the connector works with a diagram? It would probably be easier if we start from the high level.
I love pictures.
So here I have a screen that I have shared. And let me know if everyone can see the screen.
You got the screen?
Great. So it's actually a two-step process. Let's say, you as platform operator, the first step is you will come to AWS, whether it is through the EKS console or our command line tools or EKS APIs. You start with a step that is registering the cluster. And as part of that, you would provide some basic metadata such as the cluster name. And after you initiate this registration intent, EKS is going to generate a manifest file for you to download. Now, as a second step, you would take this manifest file and go to your remote cluster. And this is outside the realm of AWS. You take the manifest file, go to your remote cluster, and just apply it through, whatever cluster change mechanics that you use today. Apply that manifest file. This application process itself is going to start pulling the connector image from ECR and finished automatically the connector installation, as well as some initial authentication with AWS. By the end of that, the connector itself would initiate and maintain a connection to AWS EKS. And from which point on, you would be able to see this cluster showing up on your console, see it show up in any API or command line query of this cluster right next to your EKS hosted cluster in the cloud. Now, you can connect one or more clusters to your AWS account, even in the same region. You just need to repeat this process each time. For each new cluster, you generate a new manifest file, apply to the corresponding cluster, and you can do this, connect the cluster from your own on-premise data center and any colo, or you can connect a cluster from another cloud provider, or even let's say the self-managed Kubernetes clusters that you have deployed on EC2s in AWS today. So this is at a very high level how the connector works today. So
I'm assuming when I go register my cluster, I need some IAM permissions or something set up for the cluster to be able to connect back and do things within EKS, right?
You do. And now actually Raphael would be able to show you in action how those permissions should be specified, and then also put everything that you just see on this diagram in terms of the real console workflow. So I think we can switch to probably Raphael's desktop right now.
Sure.
And I love that manifest file that I get is just a Kubernetes manifest. I can deploy that through CI/CD. I can kube control apply it however I want. It's just I get an app essentially, and the controller or the connector in this point is to me just a YAML file. It's an app that I deploy. If I wanted to like roll that into whatever customize or tooling that I have to apply workloads, it's just a raw manifest file, and I can put that in the cluster, and then everything else at that point is taken care of by Kubernetes with the install and everything else.
Correct. Yeah, you're correct. We're basically using all Kubernetes native resources here, so we're not installing anything on your host, for example, on your nodes. So it's all native Kubernetes resources, as Lucia mentioned as well. So yeah, I'd love to go through a demo with you all, so you can get a sense on how easy it is to connect any Kubernetes cluster to Amazon EKS. So to try,
are you able to make the screen a little bigger?
I am not sure.
It's all right. If it's video, that's fine. We'll talk through it.
Yeah. Okay. Sounds good. Let me know if it's not visible. So to try out the EKS Connector, all you need to have is an AWS account, of course, administrator permissions on the cluster you want to connect, and outbound connectivity to AWS Cloud. I'll talk more about the network part later. So I have recorded this demo just to speed up the process a little bit, and we could make sure we cover it all during the talk. Of course, I'm very happy to take other questions. So let's get started. So the first thing you need to do is to log into your AWS account using any user that have enough permissions to manage EKS and IAM resources. In this case, I'm using this user called Kubernetes admin. And for this demo, I'll connect a local KIND cluster running on my laptop. So the end state for this demo is to display this local cluster on Amazon EKS console and navigate through the resources just like you could do with any native EKS cluster. Before we get started with the registration itself, we need to create the necessary roles to make it work. So the first one is a service linked role. So this will enable Amazon EKS to manage other AWS resources on your behalf. So you can create using IAM console or any other client. For this demo, I'm using AWS CLI. So you should be able to see an output very similar to this one. It seems like it worked. So the second role, which is the role that will be assumed by the EKS connector agent running inside of your connected cluster, right? So this will be used to communicate back with AWS Cloud. So you can, again, create it using IAM console or CLI. And first, I created this policy document to associate with the role. So the permissions I'm associating with this policy enables the connector to talk back with the System Manager service, or the SSM service, which is actually the service that we use to establish this connection channel between AWS and the connector. So this policy will allow us to create a control and data channel to enable this communication. With this, the data flow for the request when you navigate through EKS console will go through EKS and SSM service until it finally hits the agent running inside of your cluster. So first, I'm creating the policy document, and then I will attach the policy document to the role we just created. So once you've got both roles created, you're basically good to go and move on to the fun part. Okay, very good. So to register any cluster to EKS, you can basically use any client, right? So you can use EKS Console or AWS CLI or EKS Kernel. For this demo, I'll use the EKS Console just because it's more visual. So you can go to EKS main page and click Register Cluster. First, you can provide a name to identify your cluster. In this case, I'm providing Container Day Demo. And then you can select the provider where your cluster is running. So in this case, since it's a local kind cluster, I'll just select Other as the provider. Next, you can select the role which will be assumed by the agent running inside of our cluster. This is actually the role we just created, right? So it's a one-click process. There you go. So the first thing you're going to notice is that the cluster status is pending. This is because, as Rachel mentioned, this is a two-step process. So the first step is to register cluster in the EKS API, and the second one is to actually complete the registration in your cluster. So you're going to notice that there's this warning message and a download button. So you have to download the manifest file, which contains all the resources required to install the EKS agent on your cluster. All the resources, they will live under a specific namespace called EKS Connector. And you can inspect all the resources there before you apply, of course. So you can use kubectl or any other mechanism to apply this manifest, for example, GitOps operator, right, as we just talked. So if you go back to the console and hit refresh, you're going to see that the cluster is now active, which is a good sign. It makes let you know that the cluster registration is over. And now the next thing you're going to notice is that a warning message saying your user doesn't have permissions to see the resources in the cluster. And this is actually expected because we rely on native Kubernetes authentication and authorization mechanisms to impersonate the user logged into the console. So to be able to navigate in the console and see the resources there, you need to create the cluster role and cluster role binding to map your AWS user to their role with necessary permissions to see those resources, right? So the IAM you're using to log into the console will be displayed in the warning message. So this is actually helpful to help you create and map the role to the right user. In case you're familiar, this is actually pretty similar to the way IAM Authenticator works today. So first, you need to grant permissions for the EKS connector to impersonate the user you're using to log into the console. In our documentation, we provide a sample manifest file so you can follow there. So just download the example from the documentation and inspect it. So before you apply, make sure you replace a variable called IAM_ARN with the IAM_ARN you're using to access the console. So as you can see there, this is going to be displayed on the warning message. However, in case you missed it, you can also use the AWS CLI to get the same information. So you can just use AWS CLI, STS, get caller identity. So once you get the IAM_ARN, make sure you replace in the cluster role manifest file before you apply. Once again, you can use any mechanism you want to apply, including GitOps. Right. So now the agent has enough permissions to impersonate the user. However, you need to make sure your user have the permissions you want to access the resources, right? So again, if you go back to our documentation, we provide another example in the documentation that you can download as a base manifest file and change the permissions as you wish. In this case, I'll create a cluster role with permissions that basically lets me see all the resources inside of the cluster. However, you can restrict to specific resources or maybe even specific namespaces depending on the use case. For this, we use regular Kubernetes RBAC system, so it should be something that you're already familiar with. Again, make sure you replace the IAM_ARN variable before you apply with the IAM_ARN you're using to log into the console. And then once you apply the cluster role binding, you should be able to go back to EKS console hit refresh. And then the first time it loads, it will take a couple of seconds, and then you're going to be able to see all the workloads and the nodes running in your cluster anywhere, including your local cluster. There you go. So as I mentioned, since this is a local cluster, this is my desktop node. And then you can inspect that to see all the configurations, for example, the kernel version, the container runtime, the kubelet version, all the containers, pods, conditions, stance labels, basically every single relevant information about your node. Also, you can navigate back to see the workloads running inside of your cluster, right? So you can see all the namespaces are there. Of course, this will depend on which permissions you got. And then you're going to be able to navigate through these resources. So for example, you can navigate inside of the EKS connector itself. So we're going to see the EKS connector has 2 pods, and each pod contains 2 containers. One is the connector agent, and the other one is the connector proxy. So the connector agent is actually the open source SSM agent running container mode. And the proxy is actually the bridge that will talk with your API server. So that's pretty much all I wanted to show for the demo.
And to bring up what you were mentioning earlier, if people aren't familiar with SSM, the session manager tunnel, it opens a secure TLS socket to AWS APIs and then tunnels all of your traffic through that. It's similar to, making a TLS connection to Amazon for any sort of API calls that you're doing. I noticed there was one question about SSM channel if it was using mutual TLS. And mutual TLS is a very specific implementation of both sides have a certificate. And in this case, AWS has a certificate. The traffic is still encrypted over that certificate channel, but it's not. Mutual TLS is like service to service. I need to tell everyone's identity. So SSM is using a WebSocket tunnel to traffic that information. But to the point of using SSM is you don't need VPN. You don't need a direct connect. You don't need something else to secure that traffic from my Kubernetes cluster anywhere, whether that's an anywhere cluster or a cluster that runs anywhere. If it's a compliant Kubernetes cluster, that tunnel can be created by an outbound connection without any other further networking requirements, correct?
Yeah, that's correct. So the communication will always be encrypted. You don't have to worry about that. And if you want to learn more about how SSM encrypts the connection and the socket, you can go to SSM documentation. In specific, we basically use the very same technology. So it's all there. And SSM agent is also open source, right? So you can go to their GitHub page to learn more about it.
And it's being used for a lot. It's more than just EKS Connector. If anyone doesn't know as well, if you're using Session Manager to replace SSH on your EC2 hosts, you can use Session Manager for a lot of different ways to securely connect into Amazon, which is, I don't know if people that may not know that. It's something that is being used all over the place as a way to securely connect any environment, any network back into the AWS APIs through a tunnel. I did use it a lot at a previous job for replacing SSH, where I didn't need SSH keys, I didn't need users. We use SSM directly on EC2 instances that I didn't need a VPN or something to get into those EC2 instances. All I needed was my AWS credentials.
That is correct, yeah. And the technology is the same. However, what is particular to this use case is that we're using the SSM agent in the container mode, running as a container, as a pod inside of the cluster. So it actually doesn't have the same access that you usually have in the host itself, right? So it's a much more restricted access just to talk with the API server itself.
Right. So traditionally, I install the SSM agent on any machine, which if you're looking at other, like you can run SSM agent on your home lab and connect them back and then use that tunnel to get to machines anywhere. Traditionally, it's installed as an agent, systemd, something that runs on the box. In this case, because it's running in a Kubernetes cluster, like you mentioned, we have multiple pods, and one of those pods is that proxy that allows me to get back to a secure connection back into AWS.
Exactly, yeah, that's correct.
I also like how the IAM credentials are set up the exact same way that I would do any EKS cluster, where I have that basically mapping of my credentials to the console need to be able to see specific things in a cluster. So if you're working in a large environments and only certain people can see certain clusters or specific namespaces within those clusters, you can isolate those things at the console level. And so it's not just anyone that can see the EKS console can see everything in every cluster, right? Teams, you can isolate by team and by cluster.
Yeah, and the nice thing that we're using a native Kubernetes RBAC system, right? So people that are already familiar with it don't have to learn a new thing. So actually, I can go through the authentication authorization piece in more details real quick. So first of all, since the connector is based on System Manager, the SSM agent will perform the authentication back to AWS, which we will assume the IAM role we created in the beginning of the demo, right? And this IAM role is informed in the register cluster API call. Once the EKS connector actually establishes the connection back to AWS, it will act as a proxy and forwards all the requests from the EKS console to the API server, right? So the EKS connector service account needs to have impersonation permissions to talk with your API server in the behalf of the user logged in the console. And of course, as you said, right, to define which resources the user actually have access to view in the console, you can use regular Kubernetes RBAC system to bind the necessary permissions to the cluster role object. You have to be mindful that the subject for the role binding is going to be the AWS IAM ARN, right, which is displayed on that warning message, or you can get by running AWS STS get caller identity. So on the IAM side, the very same IAM identity you're using to access the console needs to have permissions on EKS Access Kubernetes API in their policy. So these two together, the IAM permission and the RBAC permission together will have enough, will make the authentication authorization process go through, so you have access to the resources.
Cool. Another question here from the chat. Thanks, Isaac. Li-Chun, can you talk through some of the other benefits? I know we can see the console, the cluster, any cluster in the console. What's coming on the roadmap, and what else do we want to do with those once we've connected them to the EKS control plane?
Right. So this is, connector is just a beginning. You can connect the cluster and see it. But over time, EKS as overall, we're going to add more features that is bringing a operational consistency between the cluster that you run in the cloud, in AWS Cloud, and any connected clusters, including but not limited to EKS Anywhere cluster or any other cluster you connected through the connector. And these capabilities would range from config management, and we talk a lot about GitOps driven cluster config management in all the previous sessions. You can expect that to be something you should be able to use not just on EKS cluster in the cloud, but also on EKS Anywhere and possibly future connected cluster as well. And you can also expect, let's say, manage add-on. It should be something that is you can install on connected cluster in addition to EKS Cloud cluster. So over time, we will add more and more features such that you don't have to tell the difference between a cluster running in the cloud versus a connected external cluster.
At some point, you'll be able to manage those clusters, like you mentioned, manage add-ons through the EKS API, because those clusters are also connected back to that control plane.
Yep.
Awesome. And we haven't even mentioned, like, what does this cost? Like, what's the difference of, like, I need to run this, I need support, something has to be in there for how much this costs for running these clusters.
It's free. The feature right now is in public preview, and it's going to be free to just see the cluster show up on your console. And we think, that is something you get for free for most of the other features. So with the visibility, free of charge.
That sounds like a great feature to me. I mean, free is always a good feature.
And I actually has been monitoring some of the questions on online, and I believe there is a question related to networking. I'll let Raphael dive deeper into the specific networking question there. But one thing, question haven't been asked but related is regions. If your cluster is not running in a location that has an AWS region, actually you can still connect it to AWS because there's no direct dependency. between a AWS region and the location of your cluster. But we really recommend you to pick a AWS region closest to your cluster location to minimize any network latency, which could cause UI lagging, for example. So if you have a cluster in Tokyo, technically you can connect it to US East region, but it would have been much better if you connect it to the AWS region in Tokyo. I know there's a question about, does the connection have to go through a private subnet, or maybe if you're running the cluster on-prem, do you have to open up a firewall port to let AWS reach into your cluster? But, Raphael, you want to comment on that?
Sure. Yeah, of course. So actually, the connection between the cluster and AWS requires only outbound connectivity from your location to AWS Cloud, because this connection is going to be established as a socket right from the agent to AWS Cloud. So EKS or AWS will never reach inside of your cluster and initiate a connection or a request, right? This will always go the other way around. And then once you navigate through the console, the EKS API will use this already established connection to navigate and call the agent and request for all the information. But this is always initiated by the user itself. EKS will never initiate any request to the agent. And
that goes directly to Isaac's other question here on, does it work with air-gap clusters? And in this case, you do need an active connection, at minimum an outbound connection available to go to the AWS APIs. So if you don't have internet connectivity to your clusters, that won't work. Do you know if this works with if I have a network proxy, can I go through a proxy and then do that connection?
Yeah, so proxies, they can introduce some latency, which could be potentially a problem, as Lichun said. But again, this doesn't have to be a public internet connection. So for example, if you have any private link to AWS, this should also work.
And how about, does this do anything for logging and auditing in the cluster? I know we're making a connection, we're seeing it in the console. Is there anything additional that this integration gets us?
So I would say EKS Connector itself may or may not be in the implementation choice, but again, we will bring feature parity between what you could do on in the cloud and any connected cluster. Logging and auditing is one of the key tasks that a lot of our customers would have to do on the cluster management. So it is something we will want to bring feature parity as well. We just don't want to, design how that should be implemented in this one session.
Yeah, and anyone with a Kubernetes cluster is free to still install the CloudWatch logging agent to send their logs to CloudWatch. That's not something that you need the connector for. That's not something that you can set that up in any cluster that is still just sending those logs. As long as you have IAM set up to be able to push those logs into CloudWatch logs, that's something available today with and without the connector.
Correct. Yeah, we intentionally didn't design the connector to be a single agent that do everything. Would be too powerful. So yeah, it's decoupled. You can install agents as you want and as you need.
And lastly, from a privacy standpoint, like what kind of data that we do send, one thing we want to make sure is we don't send or store any data that is not requested by you or authorized by you. So right now, the connector only will send data if you have initiated some action from the console or have called an API. For example, on the console, you see cluster configuration information, what paths or nodes are there. The connector will retrieve those information from the Kubernetes API and relay it back to AWS so we can display it for you. But we don't store those information, and the connector also don't volunteer those information. In the future, we might store something just to improve the UI optimization, but it won't be stored unless it is authorized by you.
Great. Anything else we want to talk about with the connector before we drop for a break? No?
I think we're good.
Thank you so much, Lichun. Thanks, Raphael. When we come back, we're going to shift a little bit from cluster management and then talking about CDK and ACK, which are two open source projects for working with workloads inside of Kubernetes clusters. So stay tuned, about a 15-minute break, and then we'll be right back.